I want to walk through a bug that sounds like absolutely nothing on one of our measurement pages. You could just refresh, not click anything, not type anything, and a little goal achieved celebration would pop up on its own, congratulating you for something you didn't just do. And your first instinct is, okay, that's a one liner. Find the message, show up, tell it to stay quiet, move on. But here what I love about this one. Fixing it properly meant three things we didn't see coming. We had to throw out something we'd literally written down as a fact because it turned out to be false. We had to chase a bug that was hiding behind a dead end and give us zero evidence. And we found out the thing that we fixed didn't touch one card, it touched three, all from a banner that looked like nothing was good news. This one little fix and go live. So let's pull the thread. So the first thing we had to do was throw out one of their own facts. Somewhere in our notes it said flatly, a goal that already meets its target will never close itself. It only closes when you punch in a new result. We'd written that down. We believed it. We were about to build on top of it. Now, one of our hard rules is that before we touch any code, the very first move is to go read the live code, not to the notes, the actual thing that is running. And that's what we did. The node fell apart. On a refresh, the system absolutely closed and already met goal on its own and popped the celebration, which was the exact ghost we were hunting. And the lesson isn't oops, wrong note. Everybody writes a wrong note. It's that everything we've written about your own code is just a rumor until we go rechecking it against what's actually running. No matter how sure it sounds, reading the code again is cheap. Building on a rotten fact is not. Okay, there is the part the whole thing is named after. When you load the page, the app sends out a little results are loaded announcement, and our goal checker is listened for it. Obviously suspect, right? So we followed it. And the announcement reaches the checker and then just dies. Because it goes out without saying which test it is about, the label blank, and the very first thing the checker does is no test named. I'm out. And it stops here. The trap. And it's a good one. The stop leaves no trace, no log, nothing. A checker that quietly bails looks exactly like a checker that was never ever involved. So it's you hit a dead end while hunting on alone that quietly resaves the card test value and the saves fail fires a second signal. And this one name, the test, that's the one that actually closes the goal and pops up the confetti. The loud suspect was innocent, the quiet one did it. Here's the next twist. When we first sketched the fix in our own note pointed at one little card, the main two-legged version of the test. But then the recon caught something. There was actually two different ways the value gets resaved. When the page loads, the two-legged card does it one way, but the left leg does it the single leg a different way. That didn't even exist until you unlocked it. And unlocking rebuilds them from scratch, and every load which resaves the value through a totally different path, and all the three cards run on the same checker. So if I'd fixed just one, I noticed it, it would have looked done. It would have passed a quick test, and that's the one, and left the exact same bug sitting on the other two. That's why we never fully trust a file and a line in a note. It's the starting point. You recheck it. It's not gospel. The note wasn't wrong. It just hadn't seen the second path yet, and the real fix covers all the three. Alright, now that we've actually designed the problem, we need to hush the celebration when it is automatic unload save, but we can never hush it when a real person types in a real number and earns the goal, and that's the key. Those two mistakes are not the same. If we accidentally treat a on save like a real one, worst case is a stray congratulations annoying, whatever. But if we accidentally treat a real achievement on a unload one, we silently eat the moment someone actually earned it. And for a app built to celebrate a 7-year-old's hard work and progress, quietly swallowing the real win is the worse than the occasional stray popper. The lazy fix, the obvious hack, is a timer. No more celebrations for the first second, but a timer is a guess. But it guesses towards a bad failure. Instead, we use intent on every load. Every card is marked "Don't Celebrate", and that mark clears the instant you type into it. And behind the scenes, refill doesn't count, only a real keystroke, so it releases on a human, not a stopwatch. So we take it in for real, live site and tested on the throwaway account. And the test had its own lesson, the lazy way to confirm a fix that hides something is. Load the page, see no celebration, call it done. That proves nothing. No celebration is exactly what you'd expect to see. The whole feature just broke. The working mute and dead feature look identical. So instead we prove the positive stuff on it. On refresh, we are goal met. Celebration stayed quiet, but the goal generally closed and the dashboard shows done. That tells us the logic still ran and we only muted the announcement. Then the mirror test, the one that guards the scary failure. We typed a real new number in and earned a goal, and a celebration did fire. Light mode, dark mode, and a fun wrinkle. We went hunting for a log to confirm the close, and there wasn't one because the checker only logs errors. So the log was normal, not a bug. When success looks like absence, you have to prove something actually happened. Let me close on the most honest part, and this is about me, not the code. The sharpest mistakes the whole session weren't the computer's, they were mine. As the planner, I told the tool to update a bookkeeping number to the wrong value. And the tool didn't just do it, it ran a quick search against the real record and saw the number I gave didn't match. And the stop and flagged it before anything got written down. And earlier, a little piece of my own record keeping had quietly drifted off, and that same "go look and don't assume" habit caught it too. They were both my errors, and exactly why we work this way. Not because the human is always right and the tool just obeys, because being confidently wrong in the number one source of mistakes from either of us. Just check against reality and a cheap fix. And here's why it matters. A fake "you did it", a tiny trust leak. Teaches someone something means nothing, and you've cheapened every real one. The same care that catches a false celebration is the care that keeps a real health score honest. For someone defending their marginal decade, same product. Next, we rebuild the feature. This one blocks and a base until actually verified now. You just assumed it.
Let me walk through a feature that sounds like nothing on our measurement page. When you finish a test, there's a little button, set a goal from this result. And the job for this piece was just, if you already have a active goal for this exact test, it does not allow you to duplicate it. That's it. One sentence. And your gut says, easy, go look up the goals. If there's a match, stop, done, ship it before lunch. And you could, but I want to show you that there's three things hiding in that one sentence because getting it right meant understanding how two values that look identical can quietly betray you. A safety net in the code, and it turns out that never actually caught anything. And my favorite, proving the fix worked by watching the database, not just trusting the screen. And the feature itself is about 10 lines. The care about these 10 lines say the whole thing.
Here's the first real gotcha. To catch a duplicate, we compare two things: the ID of the trust and whether the goal is still active. Both of these scored as a test, and comparing the test for equality is the same word as word, is totally safe, but right next door is a trap. The goal's target is scored as a text, and the second you compare the text to a number, is this higher than this one? You don't get a number logic, you get a dictionary logic. So 18 comes out less than 5 because it starts with 1. Think about that. In a fitness app, someone's real target could silently downgrade and nothing would ever error out and telling you tell you. So we made a deliberate call, the deliberate check only. Ever ask, is it the same test, still active? The test answer honestly, and it never compares targets at all. We left the whole keep the higher one ideal out on purpose, because knowing something tests it isn't the point. Knowing which question you can safely ask text, that is the point. Now here's the decision that isn't really a coding decision at all. It's a values decision. To check the duplicate, the app first has to go fetch your goals over the network, and the network fails. You lose signal, something times out. So the question is, if the lookup fails, what should the button do? And there's only two honest answers. Either you fail close, you cannot confirm, so it won't save, or you fail open, I cannot check, so we'll just save it. And we chose fail open, and here's why. If we fail open, and the worst part is, you end up with a duplicate goal, which is mildly annoying and easy to delete. But if you fail close, that is the worst trap. You tap, save, nothing happens. There is no explanation, and it's because the network hiccup. You can't even see. That's so much worse. So we picked the favorable failure on purpose. Honestly, once you have decided which failure you can live with, the code is the easy part. Okay, this is the part of the testing earned. Around the lookup, we've written the obvious safety net, a catch block that says if fetching your goals throw an error, log it, save it anyways. Look right, textbook, so we tested it. We deliberately killed the network, and we got this weird result. It goes through, which is what we wanted, but the log line we wrote for exactly this case never prints, and we traced it. Here's the twist: our data helper doesn't throw when the network dies. It quietly catches what itself hands back, and normal results that it says no data, there's no error. Here's an error. So on ordinary network, failure never hits a catch block at all. It comes back through the front door wearing an error badge. Our safety net, as we hung over a stream of water, never runs through. The code wasn't wrong. We proved that the catch doesn't fire. It's the thing generally throws. It just couldn't catch the failure that actually happened. So we added a branch that reads the error badge and logs there. Same behavior, but now a real failure leaves a fingerprint instead of a silent hole. A safety net that never once seemed to caught anything. Don't trust it. Go and check it. Here's the discipline I want to leave with you. The lazy way testing this is just use it. Tap the button, read the message, call it done. We didn't trust the screen for a second. The single case we checked by going straight to the database and counting the actual rows, because the screen and the data can lie. To lie to you both directions. It can say saved when nothing got written, and it can say nothing and a row quietly shows up. So 5 cases, duplicate already there. Tap save, row count exactly the same. You know that you already have a goal message. Fresh test, save makes one row, mash the button twice fast. Same row, because it itself is the instant you pressed it, it killed the network. The save still lands and our fail open proved by a new row, and the button survives, and the page wiping and rebuilding the whole section. Every one of those is a claim about data, so we settled it with data. It looked like it worked, is a guess. The count went from 10 to 10, and that's the answer.
Let me be straight about what this does and doesn't do, because the honesty is the kind of the whole brand here. This check is a guard at the door, not the law. There's no rule about the database itself about you cannot have 2 active goals on one test. The whole thing lives in the app code, and there's a tiny unavoidable gap between the moment we have checked the moment we save if 2 devices went off at the same instant. A duplicate can still sneak through that sliver. We don't bury that. We wrote it if in the decision log. We truly airtight version is a rule at the database level, where it's structurally impossible to score the duplicate no matter what the app does. That's real. Separate job that has its own risk, and pretending our app side check is the same thing as exactly the overclaiming we try never to do. So the honesty headline is, this makes duplicates rare and gives you a clear message when it stops one, and a bulletproof version is on the list. Call it what it actually is. So here's what I can take away from this one. The tiniest sounding feature that are where your sneakiest assumptions hide, because they sound too simple to bothering examine. Don't let them save the same goal twice. That's one little sentence hidden a data type that lies if it compares it wrong, and a failure choice that actually a value call, and a safety net that hung over the wrong stream, a pile of claims that only databases could settle, and a limit we chose to name out loud instead of hiding it. None of that is exotic on its own, but together is a whole difference between something that looks done and something that was not done, but we needed a little bit more information. And the big picture, the thing that I keep coming back to, is shipping is cheap. You can ship anything. Verifying it and being honest about where it stops is the expensive part. The whole part, putting your name on. The 10 lines were never the job. The care around them was.